Hello YouTube, this is Chrono16 here. Uh, Today's video is going to be about, once again, and this will be the last video that I'm going to make about it unless something drastic happens, is Asteroid 2005 YU55. And the reason why I'm making this particular video is because I've had a lot of emails with people asking what would happen if Asteroid 2005 YU55 hit Earth. Well, I found this program from Purdue University in London that they've developed to simulate the impact of a projectile, asteroid, comet, whatever, coming into the planet. Now, we know the diameter of 2005 YU55, and we know the density of it, and pretty much the velocity that it's traveling, and possibly how fast it will come into the Earth if it were to hit the Earth. If it were to hit the Earth. Now, I want to make this disclaimer. I'm not saying Asteroid 2005 YU55 is going to impact Earth. I am simulating with this program called Impact Earth from Purdue University College in London what would happen if 2005 YU55 did by some crazy chance come in and hit the planet. Now, from the last video that I made about this asteroid YU55, we know it's going to be traveling above the plane of the Earth up here. But if it were to stray off course, it would probably come in at an angle of anywhere from 90, probably about 90 degrees or so, anywhere from 80 to 90 degrees. So let's go ahead and put it at 90 degrees. And we're going to simulate that it's going to hit water. Okay? We're going to simulate that it's going to hit water. And let's just say that it hits somewhere in the Pacific Ocean. It doesn't even really matter what ocean it is, but you're on a coastal city. This will simulate what will happen. Okay? Now we got the diameter here, the density here, the impact velocity, which is 14 kilometers a second, the angle as it comes in, and the depth of the water I set at, let's say 1,500 feet. And we're, for example, going to be 250 kilometers away, or let's just go ahead and put it out here, 250 miles away from the impact of this asteroid. Okay? We're going to go ahead and calculate this now. Now, the animation on screen is just an animation. It's nothing that has anything to do with the actual calculations. It's just an animation calculating things while it's calculating, so to speak. Okay, so here's the results here. Now, the atmospheric entry really isn't all that important, but it just basically, well, actually, this is all important. It says it breaks up basically at 36,300 feet. The energy equals that of 10.3 megatons. And the global damage, the really important stuff here, says that the Earth is not strongly disturbed by the impact, and the losses are small. The impact does not make a noticeable change in the tilt of the Earth's axis at all. The crater basically says the final crater depth would be at 1740 or 1,740 feet under the water, if it were to hit under the water. The ejectile, let's say you're on the coast of California, for example, a fine dust would appear 4.95 minutes after the impact, with occasional large fragments falling out of the sky. So if you're on a coastal city somewhere, or somewhere in California, that's what you would experience in the simulation. The thermal radiation would be very little because it evaporates. No fireball is created, therefore there is no thermal radiation, is what it says. So it wouldn't be any thermal radiation because it hit the water. The seismic effect, there would be an earthquake of around 6.8 on the scale because of it. And it will be felt noticeably by people indoors, especially on upper floors of buildings. Many of the people do not recognize it as an earthquake. So that's what that basically says. Standing motor cars may rock slightly, vibration similar to the passing of a truck. All right, the air blast from this thing would arrive approximately 20.3 minutes after impact, and the winds will be about 15.7 miles per hour from this thing at 250 miles away. Now, the tsunami, now obviously there's going to be a tsunami, okay, if this thing hit the water. And the tsunami, as you can see, would be quite significant, actually. Uh, let's see here. The impact generated tsunami wave arrives approximately 56 minutes after the impact. The tsunami will be anywhere from 6.2 inches or to actually 79.1 feet. So it could be from anywhere from 6.26 inches to 79 feet. That's a pretty good size tsunami if that were to happen. So obviously, if that did crash into the water here on Earth, the bigger effects would be from a tsunami for any coastal cities around the ocean area where this thing would, theoretically hit. So there you have it. If YU55 were to hit Earth, the main damage from it, if it were to hit water, would be a tsunami that could possibly get up to 79.1 feet, depending on your location from this thing, anywhere out from 250 miles from it. Now, if it were to hit land, obviously the effects will be different. We can calculate that real fast by going in here and switching some things up. Obviously, you don't want to switch the main parameters up of this thing. Okay, let's go here, and we're still gonna put in 250 miles out from this thing. Okay, if it were to hit land, is what we're calculating now. And we're going to put that angle again at 90 degrees, and sedimentary rock is what we're going to put it as. And let me just go over this, make sure I got everything pretty right here. I think that looks correct to me. Let's calculate the impact on land now. If you're 250 miles out from YU55, and if it hit 250 miles out on land somewhere, wherever it hit at, this would be the effects that it would have if it hit land and you're about 250 miles away. Atmospheric entry again, it's about 36,300 feet. That's all about the same. Now the global damage would be, I would think, no, it wouldn't be no global damage. Obviously, it wouldn't cause the Earth to tilt or anything. The crater shape is normal in spite of atmospheric crushing. The crater diameter would be about 5.98 miles created from this thing, and it would be 1,920 feet deep if it were to hit land. That's pretty damn deep, guys. The ejecta it would arrive 4.95 minutes out. Fine dusting with occasional large fragments, so that didn't really change. The thermal radiation, there would be no fireball created. Again, this is what it says. And the seismic effects would be a earthquake of 7.1, which is more powerful than the last one if it hit water, and that's pretty noticeable. Felt indoors by many, outdoors by a few during the day. At night, some awaken. Dishes, windows, doors disturbed. Walls may crack, make a cracking sound. Sensation like heavy truck skirting building. So that'd be pretty noticeable, obviously. An earthquake of that size. The air blast would arrive 20 minutes later with the winds about 15.7 miles per hour, and there would be no tsunami because it hit land. So in other words, if it did hit, obviously ground zero, wherever it hit on the ground, would be completely destroyed, and it would create a crater a little over 5 miles wide. So, that's what would happen if YU55 hit land versus it hitting water. So there you have it. Just a short demonstration video. This software is called Impact Earth. You can go to the Purdue.edu website and find it from the Purdue University. And again, it's free software. You can do the calculations yourself. I again am in no way saying that YU55 is going to hit the planet. This was just a small demonstration showing